Iron deficiency is important worldwide because it's by far the most common nutritional deficiency. Expert organizations like the World Health Organization have said it probably affects up to 2 billion people around the world.
But amazingly, it has stayed that way for decades despite billions of dollars of aid programs that have failed to address it. And one of the reasons is we don't understand it enough at a molecular, cellular level.
Iron deficiency has multiple adverse effects on health. It's a widespread problem, particularly severe in low and middle income countries.
And in the lab, we look at basic molecular mechanisms of how iron makes cells work and how when you take iron away, the cells don't work as well. And particularly we have a focus on immune cells and the immune response. But the things that we've found mean that we can collaborate more widely, and we're working in global health settings and doing clinical trials to test how iron and iron deficiency influence immune responses in people.
Iron is important for antibody response to vaccines because B cells need iron to survive, to produce antibodies to fight the pathogens. To test whether iron can improve antibody response to vaccines, we are recruiting especially women of reproductive age in settings where iron deficiency anemia is highly prevalent, like Kenya, for example.
The Iron Mum trial is a clinical trial that we're performing with collaborators from the Thailand-Myanmar border. We know that iron deficiency is one of the main problems that can arise during pregnancy and especially in vulnerable populations. So we're going to ask the question whether fixing anemia by giving iron benefit responses to vaccines given in pregnancy. So we'll be looking at how iron affects the immune responses in the pregnant women, but also how much of that immunity is transferred through the placenta to the babies.
The aim of our research is to find safer and more effective methods to prevent and treat iron deficiency around the world. We use stable iron isotopes to track how humans absorb iron, use iron, and store iron. Using this method, we can try to understand why some people don't absorb enough iron, and we can also investigate how much iron is absorbed from certain treatments or from supplements.
One of the collaborations we're doing in Oxford is with Earth Sciences to develop a brand new method to count iron atoms in cells so that we understand what happens in iron deficiency at that atomic level.
What's interesting about iron is it's the most abundant element in the Earth. Iron is so important in the planetary sciences, and its distribution throughout the planet has large effects on the evolution of the planet and the evolution of life. The mass spectrometers that we have now allow us to sample incredibly quickly, millionths of a second. We can analyse these very small particles very accurately, and we can do a lot of them in a very, very short space of time. And that's a very exciting opportunity for attacking lots of problems in the medical and the earth sciences.
We can measure down to attogram level, which is a billionth of a gram. So we are really pushing the boundaries of mass spectrometry to be able to try and quantify iron in individual cells.
And with plant sciences, what we're doing is to understand better ways of getting more iron into plants to use as a food that will be a better way of combating iron deficiency anemia.
So the best source of iron for humans is heme. That is normally not really abundant in plants, except for legumes. In legumes, they form a symbiosis with some bacteria, and they have like a tiny structures in the roots in which they have like a lot of heme. Same heme as in the red meats. We are exactly working on producing heme in these plants, so we are growing them and we're gonna test their absorption in humans, and we're gonna test that they are safe for consumption.
So as a result of the combination of the work we're doing in the lab on basic mechanisms, our collaborations in the university with Earth Sciences and Plant Sciences, and the trials that we're doing across the world, what we really want to do is get a new understanding of how important iron is in biology and how we can use that to improve immunity and health across many different populations.